There is a pipe buried 4 feet beneath the ground, and it has been heating this house for 11 years. No furnace, no gas line, no monthly bill. The earth beneath the frost line holds a steady temperature every day of the year, and a loop of pipe running through that earth moves that stored energy directly into the home above it. The system has no flame. It produces no exhaust. It consumes less electricity than a standard refrigerator. The physics is not disputed. The efficiency numbers are not contested. They are simply never mentioned. The global heating and cooling industry is worth $240 billion a year. A pipe in the ground threatens every dollar of it. This is the story of the technology that heats a home forever, the history that proves it works, and the industry that spent decades making sure you never learned its name. The archive opens in Korea, roughly 1,000 years before the first European cathedral was built. A low stone house sits against a hillside in winter. Outside, the temperature has dropped below freezing. Inside, a family sleeps on a floor that is warm to the touch. There is no fireplace in the room, no brazier, no open flame of any kind. The heat is coming from beneath the floor. Korean builders had developed a system they called on-dole. A fire burned in a separate chamber at one end of the structure. Hot gases moved through stone channels beneath the raised floor, then exhausted through a chimney at the far end. The stone absorbed the heat and held it for hours after the fire went cold. Archaeological excavations have dated on-dole systems to at least the 1st century BC. The system spread across the peninsula over centuries because it worked. Researchers studying on-dole structures measured residual floor temperatures of 30 to 40 degrees Celsius, hours after the fire was extinguished. The thermal mass did what open flame alone could not. It banked the energy and released it on a human schedule. They were not alone in this knowledge. 6,000 miles away, builders in the volcanic highlands of Anatolia solved the same problem using the same earth. The Derinkuyu underground city in present-day Turkey was carved from volcanic rock beginning around 1200 BC. At its deepest, it descended 11 levels below the surface, housing an estimated 20,000 people. The rock walls averaged 6 feet in thickness. Excavations measured interior temperatures, holding steady between 13 and 15 degrees Celsius year-round, while surface temperatures swung from freezing winters to summers exceeding 40 degrees Celsius. A differential of more than 25 degrees was maintained by nothing but depth and stone. The earth below a certain depth does not follow the weather. It holds its own temperature with a consistency no surface structure can replicate. The ground below the frost line is a thermal reservoir that never empties. No fuel, no infrastructure, no monthly operating cost. The same earth that sits beneath every home ever built. In 1912, a Swiss engineer named Heinrich Zolli filed the first patent for a mechanical ground source heat pump. The physics had been sitting in scientific literature since Lord Kelvin outlined the theoretical basis in 1852. The ground below the frost line maintains a stable temperature between 50 and 55 degrees Fahrenheit, regardless of surface conditions. A closed loop of pipe buried at that depth absorbs that stored thermal energy continuously. A small pump moves the fluid to a heat exchanger inside the building. No combustion, no exhaust, no fuel beyond the electricity required to run the pump. That pump consumes roughly the same electricity as a standard refrigerator, and it delivers 3 to 5 units of thermal energy for every single unit of electricity used. A gas furnace converts 1 unit of fuel into less than 1 unit of usable heat. The furnace cannot approach those numbers. It never could. By the mid-20th century, studies conducted in the United States, Sweden, and Switzerland confirmed ground source systems outperformed conventional heating by a factor of 3 to 1 across a range of climates. The technology was mature. The performance was measured and repeatable. In 1948, an engineer named Robert Weber reversed the process of his home freezer and built a system to pump heat out of the ground beneath his property. He buried a loop of copper pipe, circulated fluid through it, and connected it to a heat exchanger that warmed his home through the entire Indiana winter. The ground source system delivered heat at 1/3 the cost of the gas furnace it replaced. In 1979, a builder named John Canita installed a documented residential system in Ontario, Canada. The loop ran 300 feet through soil at a constant 50 degrees Fahrenheit. Through winters dropping to minus 25 degrees Celsius, the interior held steady between 20 and 22 degrees. The measured coefficient of performance was 3.8. The average American household spent $1,200 on heating fuel that year. Canita's home spent $180. Then the building department sent a notice. The code required a furnace. The code required a gas connection. Non-compliant. The numbers were not disputed. They were simply not allowed. A pipe in the ground heats a home forever. The industry knew this. The industry had a problem. The global HVAC market generates $240 billion in revenue every year. The United States residential heating market alone exceeds $60 billion annually. Those numbers depend on one condition. Every home must require ongoing fuel consumption to stay warm. A ground source system, once installed, consumes no fuel. It generates no monthly utility revenue. A home that heats itself with a pipe in the ground is a home that cannot be built. After the Second World War, developers subdivided open land into identical lots, oriented for road access and maximum density. The builder did not care which direction the lot faced because gas was cheap. The furnace cost $400 to install, and the utility company would send a bill every month for the next 30 years. That was not an oversight. That was a revenue model. A technology that eliminates the monthly heating bill is not an engineering choice. It is a threat to one of the largest recurring revenue systems in the residential construction economy. Building codes became the weapon. Mechanical codes are written around a specific assumption that a home requires an active combustion heating system connected to a fuel supply. A ground source system can meet every performance requirement a furnace can meet at lower cost with greater efficiency. But in jurisdiction after jurisdiction, through the 1970s, the 1980s, and the 1990s, inspectors rejected ground source installations, not because the homes were cold, but because the permit forms had no category for a heating system with no combustion chamber. The forms required a furnace. The home had no furnace. Application denied. The financial system buried it deeper. Appraisal guidelines contained no line item for energy independence. A home that cost nothing to heat was appraised for the same value as an identical home with a $2,400 annual gas bill. In many jurisdictions, it was appraised for less. The system rewards dependency and punishes self-sufficiency. The knowledge was buried not in the ground, but in plain sight, underneath permit rejection letters and code language written for equipment that needed to be sold. Today, more than 1.5 million ground source systems operate in the United States. In Sweden, they supply over 20% of all residential heating. The Swedish Energy Agency documented cost reductions of 70% compared to conventional heating across decades of metered operation. In 2009, the EPA designated ground source technology as the most energy-efficient heating and cooling system available for residential use. The Department of Energy confirmed it uses 25 to 50% less electricity than conventional systems. A residential system costs between $10,000 and $30,000 to install. The average household spends $1,500 to $2,200 annually on heating and cooling. The system recoups its cost within 8 to 12 years and then operates at near zero fuel cost for the remaining life of the structure. Basic horizontal loop systems can be installed for materials costs under $4,000. The circulation pump draws 300 to 600 watts. The pipe is in the ground. The earth holds its temperature. The physics has not changed. Korean builders proved it before the first gas line was laid. The builders of Daerankuyu proved it in stone that still stands. Zoeli proved the physics held in a modern system. Weber proved it heated a home at 1/3 of the cost. The EPA confirmed it. The Department of Energy measured it. The proof was never the problem. Every home you have ever lived in was designed to need something you have to buy. The gas line was run to the street before the foundation was poured, because a home connected to a fuel supply generates revenue for someone else for as long as a family lives inside it. That is not an accident. It is a business model. A home that heats itself with a loop of pipe cannot be invoiced. A family that owes nothing for warmth cannot be controlled through the price of fuel. The earth 4 feet beneath your home is holding a stable temperature right now. It held that temperature last winter. It will hold it next winter. A loop of pipe, a circulation pump drawing 400 watts, a ground that has been storing energy since before the first furnace was manufactured. That is all it takes to heat a house forever.